SCR or short circuit ratio is a measure of stability of synchronous generator. Generator having high SCR is more stable. SCR also improves the voltage regulation, but with a high SCR, short circuit current increases. SCR can be increased with a larger air gap, but the size and the cost of the generator increases. SCR is the ratio of field current required to produce rated open circuit voltage and field current required to produce rated short circuit current. SCR is determined graphically as follows. Open circuit voltage versus field current is plotted. Field current IF1 against rated voltage VOC is found. Short circuit current versus field current is plotted. Field current IF2 against rated current IR is found. SCR is equal to IF1 by IF2. Before derivation of SCR, let us understand base impedance and per unit direct axis synchronous reactance. Direct axis synchronous impedance is like an internal resistance of a battery. Due to it, there is a voltage drop. Base impedance Z is an impedance in which rated current IR flows when a rated voltage VR is applied across it. Z is equal to VR by IR. Let the generator is short circuited. Field current is adjusted to get a rated voltage. Let ISC is a short circuit current. Then XT is equals to VR by ISC. Per unit direct axis synchronous impedance xdpu is equals to xd by z is equals to IR by ISC, or IR by ISC is equals to xdpu, that is ISC by IR is equals to 1 by xdpu. Triangles OIF1A and OIF2B are similar. Therefore, SCR is equal to IF1 by IF2 is equal to ISC by IR is equal to 1 by X DPU. Thus, high SCR means that synchronous reactance is low. High SCR increases stability margin and synchronizing power. In a power angle curve, left side is stable and right side is unstable. Maximum power Pmax is at a load angle 90 degree. The difference between Pmax and rated power PR is called stability margin. Maximum power Pmax is equal to 3 EV by XS, where E is the induced EMF and V is the terminal voltage. High SCR implies that XS is low, thus Pmax increases, increasing the stability margin. Synchronizing power Psyn indicates how fast generator synchronizes after a disturbance. Psyn is equal to dP by d delta. P is equal to 3 EV sine delta by XS. Psyn is equal to dP by d delta is equal to 3 EV cos delta by XS. Thus high SCR, that is low XS, increases the synchronizing power. Let us consider two generators, one having high SCR and the other having low SCR. Let there is a small disturbance. Due to it, load angle increases by delta. Delta P is higher in a generator having high SCR. Increase in load angle is same in both the generators. Delta P higher means that there is more deceleration. Generator having high SCR synchronizes fast. Voltage regulation means increase in terminal voltage when a load changes from full load to no load. Phasor diagrams of two generators are drawn. One is having high SCR and the other having low SCR. Field current is maintained constant so that induced EMF is constant. When a load is reduced to zero, load current I and Ixs reduces to zero. Terminal voltage becomes equal to induced EMF E. Terminal voltage changes less in a generator having high SCR. The generator having high SCR has got better voltage regulation. Let us see the effect of SCR on a short circuit current. When there is a short circuit current flows which is of a high magnitude. High SCR means that XD is low and hence short circuit current increases. SCR can be increased by decreasing synchronous reactance excess. Xs is equal to XAR plus XL. XAR is imaginary reactance which accounts for armature reaction and XL is a leakage reactance. XAR is a major contributor to XS. XAR can be reduced by reducing armature flux. Armature flux can be reduced by increasing air gap. Larger air gap offers larger reluctance to flux. But when air gap is increased, main flux also reduces. Main flux is required to be increased to original value so that we get required EMF. Main flux can be increased by increasing rotor MMF. Rotor MMF can be increased either by increasing field current or number of turns in the field winding. If field current is increased, size of rotor conductor increases and size of the generator goes up. When number of turns in a rotor winding are increased, size of generator again goes up.